Page 10, example 2. Use a reflection matrix to find the coordinates of a reflection over the y-axis of square, SQAR, with the following vertices. Then graph the pre-image and the image. So basically, a reflection over the y-axis we learned from the previous page was this matrix, -1, 0, 0, 1. And then I'm going to multiply it by the matrix SQAR. And once we get a pattern here, we can fill in the rest. But what's going to happen is this. We're multiplying what's called a 2x2 matrix by a 2x4 matrix. So the result is a 2x4. So again, this slot is row 1, column 1. So if I multiply row 1 by column 1, -1 times 4 is -4. 0 times 1 is 0. If you add those, you get -4. And here is row 2, column 1. So if I multiply row 2 by column 1, 0 times 4 is 0. 1 times 1 is 1. So the pattern here is this. The y coordinates will stay the same, and the x are going to become the opposite. So it's going to look like that. And then we have to graph it. So here's 4, 1. Here is 7, 3. So here's S, Q. Here's A, which is 9, 0. And then here's R, which is 6, -2. So here's square. And if I graph the image, here's -4, 1. Here, that's S prime, -7, 3. That's Q prime. A prime is -9, 0. And R prime is -6, -2. So it's going to look like this. Rotation matrices. For counterclockwise rotation about the origin, the symbol is a big R. Rotation of 90 degrees. Rotation of 180 looks like this. Rotation of 270 looks like this. And what we do here is this. For a rotation of 90 degrees, we multiply it by the matrix. So it's 0, 1, and -1, 0. Rotation over the 180 degrees is -1, 0, 0, -1. And a rotation counterclockwise by 270 degrees about the origin is 0, -1, 1, and 0. And we're going to use this to do the following problems. So an animated figure rotates about the origin. The image has these following key points. Find the location of these points at the 90, 180, 270 counterclockwise rotation. So rotation of 90 degrees. Here's the matrix. 180 looks like this. And then 270 looks like this. And we're going to multiply it by the following matrix. 5, 2, 3, -1, 2, -4, -1, 2, 2.5, 1.5. So we're going to do all of these. And what's going to happen is this. If we matrix multiply, once we get the first few, we'll have the pattern. 0 times 5 is 0. -1 times 2 is -2. Below here, 1 times 5 is 5. 0 times 2 is 0. So if we look very carefully from the original matrix, what happened is it's sort of the switcheroo, but instead up top is going to be -y, x. So if we use that pattern, that's the pattern for rotation of 90. We can flip these. So the bottom row looks like this, and up top it's just the opposites. The next one over 180 degrees. -1 times 5 is -5. 0 times 2 is 0. Below here, 0 times 5 is 0, and then -1 times 2 is -2. So the pattern is going to be this. Whatever you start with under a rotation of 180, you're going to keep X is going to become negative X and Y is going to become negative Y. That's going to be the pattern here under a rotation of 180 degrees. And then the last one, rotation of 270. If we matrix multiply, 0 times 5 is 0. 1 times 2 is 2. Below here, negative 1 times 5 is negative 5. And then 0 times 2 is 0. So the pattern here is this. X, Y is going to become Y goes up top and then negative X on the bottom. So these are patterns under a rotation of 270 degrees counterclockwise about the origin. So this should be negative 3, negative 2, 1, and then negative 2.5. These are the notes from page 10 from chapter 2.